All right, so we will continue the homework problems, starting with question number 5 this time. So for question number 5, I have a green ball, and it rolls off the end of a table at 2.5 meters per second. The tabletop is 1.5 meters above the floor, and for this problem, I want to know how much time passes before the ball hits the floor. All right, so for this problem, I'm going to start by drawing a picture. I have a green ball at the top, and it's going to roll off, and basically it's going to hit the floor. So for this problem, I kind of start at position A, and I finish at position B. And for this problem, I have a vertical distance of about 1.5 meters. And it rolls off the table at 2.5 meters per second. So this is actually going to be my horizontal velocity, or my horizontal speed, which is 2.5 meters per second. Now for this problem, the Vx, which is 2.5 meters per second, is actually not important for this problem because we're essentially going from position A to position B, which means we're going in the downward direction. So from A to B, we are going down. And to approach this kind of a problem, you need to visualize this. At position A, it's kind of like you're holding the ball and you're letting the ball go. So while you're holding the ball, the initial speed is going to be 0. And once you let the ball go, then the speed will start increasing. So our initial speed for this problem is actually 0. It's not 2.5 meters per second. 2.5 meters per second is our horizontal velocity. And what that's going to mean, what that means is later on in the problem, your Vx is always going to be constant. So even when the ball hits the floor, our horizontal speed will be 2.5 meters per second. All right, so this speed is actually not important for solving the speed that we're going to find at position B. So our initial speed for this problem will indeed be 0. And since we're going down, our acceleration due to gravity is 9.80 meters per second squared. The vertical height for this problem is 1.5 meters. And I want to find the time that it takes to go down. All right, so for this problem, the kinematic equation that I'll be using will be distance equals to v naught t plus 1/2 a t squared. Since my initial speed here is 0, that pretty much means this term right here will actually just go away because 0 times anything will be 0. So now I'm left with distance equals to 1/2 a t squared. For this problem, my distance is 1.5 meters. That's going to equal to 1/2. My acceleration due to gravity is 9.80, and then I solve for the time, which is t squared. So I'm solving for this variable, which is t. Now, if I want to get rid of this 2, all I have to do is multiply the left-hand side and the right-hand side by 2. So if I multiply that by 2, you'll see that this 2 and that 2, they'll cancel out. So I'll get rid of that now. Oops. And in order to get rid of the 9.80, I will divide by 9.80 on that side, divide that side by 9.80. All right, so those will go away. And in order to get rid of this squared, I need to square root that side, and I'll square root this side. So that is going to be equal to t. All right, so once you put this expression into your calculator, you should get a time of 55 seconds, 0.55 seconds. All right, so that is question number 5, and now I'll be moving on to question number 6. All right, so for question number 6, at what speed must the ball be thrown upwards to reach a maximum height of 25 meters? All right, so for this problem, I'm going to draw a little picture. I have there's a ball, I'll call this position A, and I'll call this position B. So for this problem, I have a ball that starts at position A, and it's going to be thrown up into the air, and it's going to reach a maximum height, which is at point B. Put that in red. So hopefully you can see that from A to B, we're going in the up direction. And for this problem, I want to find out what the maximum height is. So that's this green D. What is the maximum height? All right, so for this problem, I don't know what my initial speed is, but when I'm at position B, which is the maximum height, the final speed at B should be 0. And that makes sense because when the ball starts at position A, we have a lot of speed, and then once we get to position B, we start to slow down, and once we reach our maximum height, our final speed should be 0. Since we're going up, my acceleration due to gravity will be negative 9.80 meters per second squared. And for this problem, for this problem, I kind of worded the problem wrong. We do know the maximum height. The maximum height for this problem is actually 25 meters. So sorry, I'm going to erase this D right there. And for this problem, this is going to be 25 meters. And what speed must the ball be thrown upwards at to reach a maximum height of 25 meters? Okay, so for this problem, we're actually looking for our initial speed, which is V0. So what is my initial speed at position A? All right, so we do have 3 pieces of information. We have our final speed, we have our acceleration due to gravity, and we also have the maximum height, which is 25 meters. So we can definitely find our initial speed. And for this problem, the kinematic equation that works best is going to be Vf squared equals to V0 squared plus 2AD. I know my final speed is going to be 0, so at the maximum height, the final speed is always 0. My initial speed, I don't know, plus 2 times negative 9.80 multiplied by 25 meters. All right, so basically for this problem, I'm going to do is I'm going to take this whole expression right here, and I'm going to put that into my calculator. If I do that, I get a numerical value of negative 490. And once and for this negative 490, once I bring that to the other side of the equation, I get 490 equals to V0 squared. And to finish this problem off, all I do is just take the square root of each side. And for this problem, my initial speed should be roughly 22 meters per second. All right, so that's question number 6. I do apologize for kind of messing up the information at the start of the problem. We were given the maximum height of 25 meters, and for this problem, we were looking for initial speed. So the initial speed at position A is 22 meters per second. All right, so I will do question number 7 in the next video.